Hi guys, again, my name is Ayatunji Timilehin, as formally introduced, and this session I'll be talking us through a very interesting session titled AI in the browser, right? Where are we headed? The future is AI, like everybody has said, and it makes sense to already look into the future. What does the future hold? It's loaded, but let's look at some of the things that the future holds for us as web developers and any other stack that we do. How many web developers do we have here? Do we have web developers here that you do front end? Can I see? Raise of hand. All right. So I think I would be. You can follow quite well, right? So what would we cover? We'll be looking at evolution of the web. We'll look at AI in the browser, technologies that power this nice feature, Google AI APIs, and then we'll then look at where we are headed real quick. Now, before we start, I know that we are tired, but there are some ground rules that we have to follow, right? I tend to talk very fast sometimes. I'll try to slow down, but if I do, just know that I'm just trying to optimize my performance, right? As a developer, you want to be keen on performance, right? You don't want your users waiting for the browser to load and all that. So just think I'm just optimizing my performance, right? And from time to time, please nod your head. Let me know that you're feeling me, right? Let me know that you're with me. And I have a very short demo to just show to you guys. If it works, please clap. Now, if it does not, just in case, you can raise it, right? Clap harder. Thank you very much. Now, diving right in, we are looking at the future of the web or the future of AI. It makes sense to look at where we are coming from and then where we are and then where we might be going to. We don't all have to go there. Our journeys might be different, but it makes sense to say that we have a common history, right? And then, the web has always been a database of documents. And then how are we evolving to, say, the next frontier where the web is becoming intelligent? So in this case, we'll talk about Web 1 up until Web 5. People have been arguing that there's a Web 5 coming through, but I know that we are all, we all know about Web 1, Web 2, Web 3, the new wave, and which is all there. Now, Web 1 started with the static web, where you would see things like, those were in the early 90s, right? You could almost not interact with the web. Just go there, read documents, click links. It was the static web, right? There was almost no interaction, no JavaScript and Ajax and all those technologies that now power the web today, right? So that was Web 1. It was just a read-only web. Now, fast forward to Web 2. You can read and write, right? It's called the social web. That was when, the whole Twitter, Instagram, and all that. You can text your brother, your sister, and all that. You can edit these documents online. You can read and write, basically. Now, Web 3 basically talks about the decentralized apps, right? Came up around very recently, talk about Web 3, and then you'll be talking about decentralized apps, owning your own information, such that as against Web 2, all the information was just, centralized somewhere. So now you can have your information in bits, like, talk about cryptocurrencies and all that. Now, Web 4, which is where we are talking about, what we're talking about today, right? The intelligent web, because why not? If you're a web developer, don't you think that your web or your browser or your application should be as intelligent? Because it's the new wave, right? Every other thing around us is, AI is kind of built into it, even your mobile phones and all that. Even people that are not tech savvy, they tend to use AI. So why not web developers? And there's an argument for Web 5.0. I don't know how that would turn out yet, but the future is heavy and loaded with wait and see, saying it's going to be emotional. I don't know how that is going to work out, saying machines will be able to relate and interact with us, be able to read our emotions and all that. Are you following me? Let me see your hands if you can. Thank you very much. Now, quickly, AI in the browser, what does it mean? Does anybody want to tell me? What do you think just by seeing this? When they tell you AI in the browser, what do you think it means? Can I see your hand? Any hand? Any hand? Any hand? Okay, I think I'll just tell us then. This is not a read-only session. This is a read and write session, Web 2.0, right? We are not in Web 1.0 where you only read documents. So if I ask questions, please, if you know the answer, don't be too tired. You probably want to stretch your waist and all that. So just stand up and answer me, okay? Thank you very much. Now, what we're saying is, we basically mean that you're running machine learning models directly in the web browser without needing a server. Up until today, talk about the large language models and all these other AI models. They would usually need a backend server somewhere because the models are quite large, right? And then they want to talk or communicate to these servers to get responses. If you integrate AI or you do prompt engineering today, you're most likely calling an endpoint, probably from OpenAI or Gemini or whatever. Now, we're looking at the possibility to say, I'm a developer. You know, my user lands on my website. How do I make it feel very, intuitive and very fast, such that the user does not have to wait so long, right? Models are executed locally on the user's device. You're using these technologies, you run it on the device without having to go to the server to get requests and responses and all that. And then we talk about features like real image classification and speech recognition and all these things. I'll show some of this in a bit. Now, I've mentioned running to servers to get responses. That comes to say, how then do I decide browser versus cloud? When do I have my models on the cloud, or when do I run my models in my browser? I've said a lot about saying you want your application to be as fast as possible, as close to the user as possible. And then I'll say that basically, doing some differences between these two, you know, your AI in the browser basically runs on your device. Say, talk about like Chrome or Safari or whatever browser you're using. And then on the cloud, you're talking about AWS and whatnot. But definitely your cloud models, hosted models need, internet to access them. Meanwhile, you can just use even a PWA when your models are run in your browser. When I talk about PWA, have you heard of PWAs before? Yeah, progressive web apps that can run offline. So tell me how you want to run a model offline if it's on the cloud. So these are instances you want to consider, having your model in your browser. Now, it's definitely going to be fast because there's no server runtime, right, compared to the cloud. Now, if you're also keen on privacy, there's some applications that you don't want because most likely if you're sending information to the server or to the backend, it then means that, privacy is limited compared to what stays on the user's device, right? Now, the model size is also something you want to consider because the browser is not as sophisticated as the cloud services. So if you're considering the model size, you want to look at, okay, is it as tiny enough to run on the browser? But I tell you that most times, as developers, because before you write your code, you want to envisage and you want to plan properly. Is this something that I should put on the browser, or I should have it on a server somewhere, right? But most times you want to do a mix of, hybrid approach, such that you have some on the browser or on the device, and then you have some on the server. So, that's really the best approach. But if it's tiny enough, you don't need to go to the server to get responses, right? Has any of us ever wondered how our phones are able to do facial recognition, even without internet? Right? You want to make a transfer or you want to unlock your phone. It's not having to call API. You can just quickly get your phone unlocked. Imagine it's having to wait for, a response from Apple or something, right? That can take forever. Or, does anyone drive a Tesla here? Why are you laughing? See, it's an honest question. Do you drive a Tesla? You drive a Tesla? You look like it. You look like it. Anybody? You drive a Tesla? Now imagine you are going on the road and it's supposed to give you directions and all that because basically what it does is it recognizes objects, traffic light and all that. You can imagine if it had to call APIs. You know how many times last mile or police officers would have eaten off you, right? That's because the model is inbuilt. It can easily recognize these devices and tell you where to turn and objects and all that. Now that's an example of an on-device model. Does that make sense? Now, that's the kind of thing we are trying to bring into web browsers to say this is as close to the user as possible. The user or the browser does not need an internet or network service to go to get responses. Now, going further, you don't need, if you're going to use the browser AI, you're considering that, okay, I need real-time predictions. But if you have like large language models, like I mentioned, you want to go to the cloud. And I mean, if privacy is key to you, if the model is small enough, then I mean, the browser is your guy. Now, real quick, technologies that power this browser AI. I'm going to mention a few of them, and I'm going to talk about tensors, TensorFlow, and the TensorFlow JS, and the performance enablers, and I'm going to show real quick, and you can just quickly build a small model and see it run in the browser, and the different performance enablers, and then how they vary. Now, okay. What are tensors? Basically, tensors are numbers. Your computer recognizes just numbers. The only way you communicate, you can think you're typing and writing on your code, but it's interpreted into numbers, right? That's the only way it recognizes it. So they are like boxes of numbers that you can use to do mathematical operations, talk about multiplication or whatever. So these models learn by doing math operations on these tensors, right? And then you have different dimensions of tensors, basically. You can have a scalar dimension. In this case, we're talking about probably having just a number, 32. You don't have to deal with what position it is, right, in the model. It's just a number. Now, talk about vector. That's a rank one dimension. In this case, as you can see in the image above, right, it's like an array of numbers, say 2, 3, 4. And then you need the position. Let's say I have A, B, C, D, E. If I was to pick D, I'm going to have a position to say maybe position 3, right? That's like a vector-based tensor. Now, rank 2. I know most of us must have done matrix in our secondary school or wherever. I didn't like it, but here I am, liking it. I didn't know it was waiting for me in the future. So if we're talking about where are we headed, right? I mean, it's a lot, because if I had known then, I would love it already. So it's a good thing to already start, looking into the future now. Now, matrix basically is saying that as against the vector that I mentioned earlier, just one position. As you can see, this has, the horizontal and the vertical layer. So you have to, identify the position, say position 2 above and 3 below, right? Does that make sense? Does that make sense? Sorry, you're tired. It's been a long day, sorry. And then rank 3, just as you can guess, is saying that, okay, there are 3 positions that I need. I need it top, I need it bottom, and I need it in the middle to pick that number, right? Now, TensorFlow is basically an open source machine learning framework by Google that you can use to train your models, right? Meanwhile, TensorFlow JS is like a JavaScript version or like a pipeline that you can use to run this TensorFlow. So I need to run real quick. Now, talking about the performance enablers, you can use the CPU, but it's quite slow, right? Models, AI, they are heavy. So imagine using the CPU, I would show that, but then it's like a great fallback in cases where there's no GPU, which is the graphic processing unit of your computer, right? And it's almost in all your browsers, modern browsers, your Chrome, your Safari, and all that, right? Now, the web graphics library is another processor, but it's quite faster than the CPU, and it's also in modern browsers, right? And then, but then the use case is that it's not entirely made for models, right? It was made to run graphics and all that, but because the CPU is quite slow, we will tend to use the WebGL. Now, to the main guy, WebGPU. How many of us have heard of WebGPU? Has anyone heard of WebGPU before? Anyone here? Anyone here? All right, now I bring to you WebGPU. Talking about the future, it's the next generation, and it can increase your AI speed and inference by about 2 to 10 times compared to the web graphics library we mentioned earlier. And then it's supported in Chrome. It's quite new, so now you need to enable it in the flags, right? Now, I'm just going to show you, this is the URL here. I'm just going to show you real quick where you can enable the WebGPU. When you go to Chrome and you go to flags, right, there are a lot of them that you can turn on, but for this precisely, it is WebGPU. And then as you can see here, it is enabled. It's an experimental processor that currently exists in Chrome. And there are quite a number of them that you can explore, in your spare time, right? Moving on, How do you check if it's in the browser? Just like every other thing that you check on the navigator object, you just check that if there's navigator.gpu, then run. Otherwise, let's do something else. Now let's go to the demo. I'm going to present to you Teachable Machine. It's a no-code AI tool that I'm going to quickly use to do some object recognition and then run it through time in the browser, show you the difference between these processors. Now, well, you just need to go to Teachable Machine, with google.com, and then you run the model, you run the application like this. You can run image project, audio project, or a post project and whatnot. Now, the image project is such that, now I just came with two objects so that I can show real time, right? I'm going to, can you see me? Yes. Thank you very much. Now I'm going to, now this is quite, this is a biro, this is a pen, right? We all know. I'm just going to name it biro, yeah? And I'm going to show it. When you're doing your, what's it called? You're making your, you have a new phone and you want to train it with your face such that it can unlock. We all do this, don't we? You do this, it tells you to turn your face and do that. That's you training the model, basically. And it's an on-device kind of model. So I'm doing the same thing, and I'm going to then use it in a web application, and you see the difference. So I'm just going to turn this and rotate it as much as I can. Let's leave it at 42. Now the second, I'm going to use a book real quick. I'll name it. You can have as many samples as you want, right? But a good thing to note is that you want to make sure that whatever class you're defining have as much example as each other. Like, let the examples be, equal. So that you don't have, like, for example, biro, you have like 50, and then I'm putting book just 2. The model will be quite confused, and you wouldn't blame it when it's being partial. So now we have, what here, 42. I'll try to get to 42. Here, we have 19 now. So you show it, different variants. So you can take it as my face and my iPhone trying to recognize my face, my ears, and everything. 43, I tried, almost 42. All right, then the next thing is to just train the model. We give it a few seconds, and right. You can even test it out here, right on Teachable Machine. And then, as you can see, it's saying the biro is, how many percent? It's quite not clear here, but you can all see it's not clear. What can we see? Biro is how many percent? And then the book is, now you can, my face and everything can interfere with it, because if I did like this, it would probably be seeing the book alone and all that. So the book is more precise. But the biro, I think, maybe because it's quite tiny, but it's doing the prediction quite all right. Now, what do I need to do? I'll just export this model, and then what do? I'll download it. Now, this is a code base that you just copy this code and put it in probably your index HTML. And when I download my model, what happens? The next thing is to just unzip. And I'm going to copy these files and move them here. Now, this is a code base that I've written, but this is a new training that I just, a new application that I just trained with the weights and the model and all that. Now, this is currently running. So basically, I'm just going to then test it on my local here, and I'm going to see if it will recognize the biro also. It's recognizing, and the predictability is about 0.9 to 1. Now, this is running with WebGL, because it's supposed to use CPU by default, but the modern browser has WebGL, right? You can see how the prediction is quite fast, right? And this is a book. Now, if I show you otherwise, right, to say, let's see the difference between these 3 processors. Same model, same everything. Let's use the CPU. It loads the model about 0.05 milliseconds to load the model, because it loads it the first time. It has to download the model in the browser, and then subsequent time can be faster, right? You can see how slow it is using the CPU. Can we notice it? Can we notice it? All right, let's use the WebGL. It took about 0.51 seconds to load the model, and then is it quite faster? So which would you go for if you were to choose? Thank you. Now the web GPU, the record breaker, right? 0.28 seconds to load the model, and its reference time is about 15.2 seconds. You can see how fast it is, right? Inference time compared to WebGL is about, 15.2 milliseconds compared to 53.8 milliseconds. So that's just to show us the difference between these processors, the CPU, the WebGL, and the web GPU. So back to our presentation. This is, you can scan this code. It's just the code to the code the link to the code I just shared on GitHub. So you can scan it, pull it, train your model, and see what happens. I'm going to give 30 seconds for that. 30 seconds, 30 seconds, 30 seconds. Can we move on? Let me know when we can move on. You guys are not even nodding. I said you will nod a lot. People are not nodding. Why? Okay, can we move on now? All right. Now, I'm just going to quickly touch base on this. If any of you attended Thomas' session, anybody did in the other hall? He mentioned some of these APIs, so I'm just going to touch base on them, and you can experiment with them real quick. I'll show you the link. This is the link. You can just grab it, read up about it, and see how they work. In fact, there are examples of these APIs, right, and how you can use them. So you have different APIs, like the writer API, the translator API, and the language detector API, and a lot of them. A lot of times, you're probably on Instagram, maybe Cristiano Ronaldo posted something, and you don't understand the language. You see translation or something like that, and then you click it, and it transcribes to English. How is that possible, right? So that's the kind of thing you can do with these APIs that are currently in Chrome, right? You just need to, it runs on your device. It detects your language, because a good use case would be that you're developing an application for different kind of users, not just maybe Yoruba or English speakers. You want to be able to still interact with them or communicate to them, right? Because, there's a study that says about 60% of users tend to stay on a website if he speaks their language, right? So you can imagine how well this would help you even scale or even sell more your product. Now, the good thing is that they are all inbuilt. You don't need to call APIs to get this. Now, so the last session, where are we headed? What does this seem like, right? Knowing all this currently exists, though they are experimental features, right? And I have brought it to our hearing. The feature is loaded. What can we do? Nobody thought AI would be this big. And it seems like if you're not using AI now, you're left out. Now, where are we headed? We can expect a number of things. The web GPU, which is the next frontier, can even be better, right? Because performance is key in any application that you're building, right? It will become part of our native web APIs, and then more apps would even have the ability to run offline. And then your cloud bills, having to pay because you're hosting your models on AWS and all, can become, significantly reduced. And then your browsers themselves, like we're seeing right now, a couple of AI browsers have started emerging, right? They become intelligent applications by themselves. We've come to the end, and these are, a couple of links you can use to digest and read more about some things we've just discussed. So you can scan and get a list of these links, because I figured it might be tiny or something. So just read up, and thank you very much. We've come to the end of this conversation. You can follow me on LinkedIn and on Twitter, right?
Thank you very much, Timilehin. And please, do we have any questions in the audience? Anyone? Now we're begging for questions. What did you say? All right, I'm very, very sure it's a very sound session for them and everybody understood it. You have a question? Thank you very much.
Tesla guy. Shoot, I want to get a Tesla. No, what do you say you want?
So I was thinking, assuming the book, like the book you were holding or the pen you were holding, let's say they change the cover of the pen to blue. Will it still work?
No, it won't.
Okay.
And it can. I'm not done. Now, your models, this is a very rough training, right? Have you ever seen an instance where maybe sometimes my brother face unlocks my phone? Has that happened to anybody before?
Yes.
It happens. So that can be an error. So it now depends on how well you train the model. This is not the only kind of biro that exists. Forget the color. There can be different shapes of biros. So you want to do due diligence by training it with different existence of biro that can exist. A book will not always be a black cover, right? It can even be a sheet. So then it's now left to you. You're training your model. What are the edge cases or whatever can happen, right?
So based on your expertise, okay, let's say for Face ID, for us using Face ID, it scans all our face. Will it be okay to just scan the eye only? Because based on the example you just gave, you said, like my brother face can unlock my phone. So will it be okay to just leave it as eye lens only or the full facial?
The full face, because your application is what? You want it to recognize your face. So why training with only the eyes?
Like I'm talking based on security.
Based on security. You
Yes.
train it with your full face. I mean, the models can, hallucinate and make mistakes. And that's why there's constant development and improvement to all these models and application. Is that clear? So, there's constant loop of feedback and, the guys developing and all that. If you're a software engineer, you get a lot of feedback from your user and all that. And, you improve on what you've pushed out there. Thank you.
Yes, but let's keep clapping until it gets off. I mean, this is something that is very, very new to many of us here. I'm sure everybody understands the whole concept about AIs, but now seeing it practically in action.